Hey guys, what's going on? This is Ipsec, and I'll be doing Lazy from HackTheBox. This video I may do a bit fast. I have to head out to B-Sides DC today. If I didn't do the video today, then it would be delayed like 3 days after release, which I did not want to do. So we'll do this pretty quick, and let's jump in. Starting off, we do have to do the nmap, so SC for save scripts, SV enumerate version, output all formats, then the IP address of Lazy, which I believe is 10.10.10.18. I've already done this, so let's look at the results. And we see only port 22 and 80 open. So let's open up Firefox and go to 10.10.10.18. And we see just a blank login page. So the very first thing I always do is go here and type like admin and then I'll do it in the search thing so you can see, or 1 equals 1, things like that. No, okay, let's put these in quotes. And I just try a bunch of potential SQL injections. Didn't work, so what I'm going to do next is open up Burp, go to a proxy tab, turn intercept on, and we'll capture a request. And the reason I'm doing this is so I can have SQL map running in the background while I test other things. It's always important to do multiple things at once, especially if something's just a simple recon. I did not want to click that. Default. Admin. Go over to Burp. Copy this entire request. Go back to our terminal. Go to new session, and we will v login.request. And then clear these blank lines. I'm sure there's a better way to copy this stupid request, but this isn't big enough hassle for me to Google and figure out what I'm doing wrong there. But so we're going to do SQL map dash request, login dash request, and we'll do, I think, dash dash level 4 dash dash risk 3. I always get those two reversed. So if this errors, we'll do level 3 risk 4. And that should be going soon. There we go. Just make sure it doesn't ask us for anything. SQL map. Okay, it is testing. So the next thing I want to do is let's register a user and see what happens. Register. I'm going to register IPsec, password, and I'm just putting password, and we'll try logging in. And it says we're currently logged in, and that is it. So the next thing I'm going to do is go to our HTTP history tab. Let's get this login request. It was a post. Nope, that is register. Where is login? Is this it? Oh, there is no login because it just auto-logged me in. So what I'm going to do, log out, log in, IPsec, put the password, and I want to examine the cookies. So let's go over to Burp, intercept on. If I could tab to the right window, it would be helpful. So I'm going to send this to sequencer. And what this is going to do is replay this login request a few hundred times. So we're going to start the live capture because it's got its token location with the response. Already sees the auth response. So start live capture. And essentially what that's doing is we'll send this to repeater. Click go. It's capturing, it's sending this request, capturing this response, and logging it. So we should be able to pause this, analyze now, and all I want to do is see if the login token is changing. And go to character level analysis, bit level. It doesn't have enough to do character level. So let that run. And we can actually no. I just copy the tokens and we will paste them. V login tokens. That's going to take a little bit to get off my clipboard. We can stop this. We don't need to do sequencer anymore. And the next thing I want to do is we'll try like second order SQL injections or things like that. So what that means is the developers have been told, hey, do not trust user input because users can do bad things. If you trust user input, you may have a bad time because they control it. What developers sometimes forget is that if users can control the input that goes into the database and the developer's like, you know what, I can trust anything that comes from the database. I'm not going to do sanitization checks because it's the database. The database is trusted. That's not the user. Well, if the user puts something bad in, then it becomes the developer's problem. So do that. So basic SQL injection technique, we're just ending the quote, then inserting a comment, and we'll do password, password, log in. Okay, it looks like it sanitized that well. So, may not be that. The next thing we'll do is, let's see, we'll register the name admin with a space and see what happens. Again, tabs, user exist, admin, bunch of spaces. So that's not going to work. That's weird. Duplicate. Oh, it's showing the SQL error up here. We'll do admin equals. Trying like a NoSQL type injection things, and we log in, and we get right in. So this wasn't really a valid technique. It's in the source. It's doing like removing all equal signs for some reason. So we register the user admin equals, and then when it does the check, it's valid. If you look at the decrypt.php, I can show that, but that's one way. The other way is, let's see, did this finish copying? Yeah. So here's all the auth tokens. So we can see they do vary, which means there's some type of randomness in creating this token. So if there wasn't any random, then we know, oh, there's a unique signing key that goes to all these tokens, and once we get a valid token, it's going to be good forever because there's nothing unique in that auth token. Or nothing unique signing the auth token or encrypting it or whatnot. So the next thing I'm going to do, I'm going to register something really close to admin, like CDMIN. And we'll do password, password. Log in. Okay. Now I'm going to go back into Burp, turn intercept on because I want to intercept this request. Refresh. We're going to send this to intruder. Make sure our position is set on that auth token. And our payload is going to be a Bitflipper. So I'm assuming that this is some encrypted value right now. And I don't know how it's encrypted, but if I flip a bit, it may be able to change one character. And if it changes that C to an A or something, then I'm admin. So that's what I'm trying to do. Just flip random bits and encryption, and I know that my username varies by 1 bit. So I may get lucky and become admin. So payload processing, literal value, and we will start this attack. Sort it by length, and we do see multiple different lengths. So if you go down here and look at the response, invalid padding. This hints that it's a Oracle padding attack, which we can show you right after this. We go up. Let's see. You are logged in as CDMIN. CDMIN. Let's see. Go up this response. Is this still CDMIN? It is. I know I could right-click somewhere and add a new tab and create this as a column, but oh well. User not found. Doesn't tell me what the username is. So that was probably some really bad thing that it completely barfed on. CDoin. Let's see the next one. CDLIN. C bad character min, C tmin, C lmin. So you can see me flipping this bit. I'm trying to get one that has admin. And it finished and does not look like I have any. Could have swore this should have worked. So we'll try the user BDMIN instead of C, and we'll see if we have different luck there. Or we can just send this request again. I'm not sure how repeatable this is. If it will do the same bits every time. So let's see. LODMIN, so that's bad. Let's log out. I probably have to disable intercept. I already did that. Log in. BDMIN. Password. And let's try it with this one. Intercept. Oh wait, I don't want to copy that. I just need to send to intruder. Or I could just do this last one and positions. We will paste, start attack. And this one looks like we got lucky and flipped it with admin, because this is a completely different response. So I'm guessing if I converted it to like binary, then I would have seen exactly what went wrong, but we won't worry about that. We'll just log in and verify that yes, we have two different ways we have done this challenge. So we can tools, Foxy, no, Cookie Manager, and we want to do 10, 10, 10, 18. Edit this cookie, and we will paste that. Okay. Proxy intercept off. Refresh. And we're admin again. So the last way we can do this is with a Oracle padding attack. And we knew that because of that invalid padding error message. Basically, Oracle padding is a information leak, and that allows you to brute force the key one byte at a time, and it does so by using the padding variable, which I guess you can think of kind of like a checksum that says, yes, this whole block is fine. Horrible explanation. Maybe I'll do a better one time. Or you can YouTube Oracle padding attack and learn about it. But we're going to use a tool called PadBuster. There we go. That's what it is. And if you just Google this tool, you can easily find it. So we do Perl PadBuster to see the usage. Go over to SQL map. Nothing appeared injectable, so we can exit that. And we'll name this PadBuster. Okay. So what we want to do is Perl PadBuster, and it wants the URL. So we want to go to 10, 10, 10, 18. And let me, do I have a bad cookie? Yeah, this will be the cookie we use. The IPsec cookie. So go back here. The next thing it wants is the encrypted sample. The block size, either choose 8 or 16. It's normally one of those two. We're going to do 8. And then options. So we want to do dash cookies right here. And specify auth equals that. That looks good. Let this go for a second. Okay. It's going to ask which response signature do we want to use. It recommends us doing 2, so we're going to do 2. And while that runs, let's go back to our web page. Tassos, this is my SSH key, just in case you ever want to log in and check something out. Thank you. So we'll copy this key. Going over here, we see it has brute forced 1 byte, 2 bytes, 3 bytes, and you can see 256 because it's just trying 256 different values for each byte. Go to this next one. We will do a wget on that key that I copied. We see the URL is my SSH key with name Mitsos, M-I-T-S-O-S. So we will name that to mitsos.key to make it easy. And I'm sure that translates to something in a different language. Before we can use the key, we have to chmod it to 600. And now we can ssh-i mitsos.key and then 10, 10, 10, 18. Let's go back to Padbuster. It's still trying. It decrypted the first block of 8 bytes, and it is user equals IP. Go back here. Rename this window to SSH. Okay. Wait. I didn't specify the user. While that logs in, check Padbuster, still going. So we're logged in. And we see the binary backup. It's got PEDA, which is a GDB extension. I'm pretty sure I did that in another video. We execute backup, and it just cats the shadow file. So we could copy this and try to crack this hash, but that is, I believe, SHA-512, as signified by $6, which means we're probably not going to crack this. The other thing we could do is analyze this in like Binary Ninja, IDA, or something. But since it's got PETA on it, I hate that name of the application. I don't know any other way to pronounce it, but we can just run GDB and step through this. So GDB on backup, we're going to break main, and then when we run this, we can see kind of what it's doing. So right here, it's calling system. And just before it's calling system, it is loading a variable into ESP, which will be the argument for system. So if we step twice, we get to this, and if we just, I think, x/s, examine this variable, do I just do that? Yeah. We can see it's going to be Etsy shadow, or cat Etsy shadow. So we'll step one more time to execute this call. We look in ESP, and we will see that variable get put here. The keynote is it's not an absolute path. It's just catting Etsy shadow. So what that means is how the path works. If I type ping, it knows what ping is. If we do echo path, ping is going to be in one of these locations. So if we do which ping, we see it is in /bin. So use a local sbin. It's going to run through all these and hit this. So if ping exists in any of these previous directories, then it's going to execute that file. So same way with cat. We do which cat, it's going to be in bin. So what I'm going to do is create a file called cat, and it's going to be a bash script, and we're just going to call sh. So chmod plus x to make this executable. And now, actually, before we do this will be easier to explain. So if we cat etc pass wd, nothing happens because we haven't edited a path yet. So if I do export path equals pwd path, now when I echo path, I have home mitsos in my path as the first thing. So if I do that cat etc pass wd, it should have chmod plus x cat. I don't know why that wasn't executable. Did I screw something up? Huh. Weird. I'm actually not sure what's going on. Let's see if we run backup path hijacked. So I guess it doesn't work in the actual terminal window. So if we do v test.py, import os, os dot, is it popen? I think os.system exists. If not, we can do the other one. We probably want to print that. And we get path hijacked. So if we move that cat file to be cat.back, run that Python script, it does cat etc pass wd. So that's exactly what's happening there. So let's move that cat back and edit this. So instead of echoing path hijacked, let's just give ourselves a shell. So / backup, and then we see our effective user ID is 0. So if we go to cd/root, cat root.text, doesn't output it. Why not? Because our path is screwed. So I know what happened there. So if we just less that file, we could get it. But go out of a shell, go back into this cat file. So remember when I did cat etc pass wd, and it's doing that? It's because path is loaded into my bash session. So if I just do bash, redo all my environment variables from here, and cat etc pass wd, we get path hijacked. So that is that challenge. If we go to Padbuster, we can see it has decrypted a cookie that we gave it. Remember, Padbuster has no knowledge of the plain text that was user equals ipsec. So we'll do dash plain text user equals admin now. And it's going to run that again. So this could take a little bit. But this will return us the cookie for an admin user. So while it does that, let's look into the PHP script. Is it in classes? DB user grep decode. It's in user, no. So here is the decrypt script it is using. Where was that? Did I miss it? Let's see. I probably... Yeah, it's in classes user. So I had just stripped out a lot to make it easier. So let's go back to that. So right here is why that equals thing worked. It's taking user, exploding it to remove the equals. I'm not exactly sure why it's doing that. It is using an initialization vector. It's going to show something. Maybe it was just this. List user, explode. So if we go back to Padbuster. So it says it encrypted this. So this should be the cookie. So we log out, intercept the request, go to cookies equals. I think that should be good. Send this repeated just in case it's not. I did something wrong. Let's just log in with IPsec password and replace the cookie. Turn intercept off, log in, IPsec password. Okay. Intercept on, refresh. Oh, I did cookies instead of cookie. That's it. And we see we get back to admin because that cookie says we're logged in as admin. Was there something else I was doing just before that? I don't think so. So, hope you guys enjoyed that video. Hopefully it wasn't all over the place. I like to take more time, but again, have to head out to B-Sides DC now. Take care, guys. Later.